Hello, it's Raphael here again. Thank you for joining me and welcome to our channel. Last time I talked about how a lot of these sport drinks are really harmful for children, and like everything that I said about children does work for adults as well. For instance, if you have the sugar, you're going to have tooth decay. High sodium diets have been linked to high blood pressure. Now, someone asked, well, what if you sweat a lot and you're losing a lot of electrolytes? Initially, what I did is I took the question and I just looked at the blood volume and assumed, okay, well, let's take blood volume and the maximum levels of salt in blood and see how much fluid you would need to lose. But that was incorrect because if you actually look at the amount of water you have in your body, it equals about 60% of your body weight. In essence, if you have a 160-pound person, we have to actually go into kilograms, so you'd have a 75-kilogram person, and you calculate how much water they have, you have 45 kilograms of water. What that equals out to is 45 liters of water are in your body. Not all of that's in your blood. What you have is you have three different compartments. You have the intracellular compartment, which is the water that's in your cells. That makes up about 40% of your body weight. Then you have your interstitial fluid. 20% left of your body weight, it's about 80% of that is interstitial. And then the last 20% of the 20% is your plasma fluid volume. And that's actually the stuff that you would be found in your blood. So when people talk about how you have 3 liters of blood, I'm going to use liters instead of pints because it makes the conversions a lot easier. But what I found is if we were just looking at the plasma fluid volume, you'd have to lose a liter of water, 2 of these, and replenish it with a liter of water at the same time to drop enough to actually drop the concentration of sodium, which in your blood is about 140, give or take 5 millimoles per liter. And in sweat, usually you have 16 to 105 millimoles per liter. So the thing is, if we actually said that you were sweating as much salt as in your blood, you would actually have to get rid of 2 pints for you to drop the sodium. And that's just looking at your plasma. But the thing is, that's wrong because the fluid from your plasma can end up pulling water in from your interstitial fluid. Now remember, you have roughly 2.5 liters, 3 liters, and so from this 3 liters, you can actually, that's actually what you're sweating, but you can pull, well, there's 12 liters in your interstitial fluid roughly. So for every liter you comes out, you can bring in a little bit of the interstitial fluid. And so the concentration of salts would stay about the same. So you wouldn't necessarily, you would have to do more than 2 pints of sweat. If you manage the fluid from your intercellular fluid can also leak into your interstitial fluid. And so what ends up happening is the sodium concentration in your blood will be maintained relatively the same. So in essence, for you to actually drop sodium levels low enough for it to actually be clinically significant, if you were to try to find out how much sweat you would have to produce, making the sweat the same concentration as your blood, a level where it just borderline starting to have problems, you'd have to have about this much sweat produced. 2 liters of sweat. That is about the maximum someone could potentially produce, and it's going to cause other problems. It's actually the fluid loss is going to probably cause more problems than the salt. But yes, you can end up going to that if you're producing 2 liters of sweat. That's what you would need roughly for a typical 75 kilogram person to actually need the sport drinks. I didn't actually stop at that. I actually also decided to look at a couple different experiments. And there was one that was really neat because they used 4 different trials. Their sample size was kind of small, but showed us some results. Now what they did is they separated people into one of 4 groups. One is a high carbohydrate and sodium water replenishment, pretty much your typical sport drink. The other one was a low carbohydrate with normal sodium levels, which is your diet sport drink. And then they had one with just water and one which was called the placebo, which was water with food coloring. And what they found is after these 4 trials with 3 hours of exercise, and it was actually supposed to be strenuous exercise for 3 hours, they found that the ones who were just drinking water and the water with food coloring, their plasma concentrations of sodium chloride dropped 2.5%. Here's the funny part. That 2.5% was not clinically significant at all. Pretty much it actually maintained them in the same range. And they actually found that even within the groups, there were some people who would actually have sodium concentration and they would drop to 2.5%. So it really didn't show any difference whatsoever. So if you're exercising more, if you're doing extremely strenuous exercise for more than 3 hours, then yes, the sodium chloride is actually important for you. And that's why if people who are in military will actually have salt tablets because sometimes they don't necessarily have that. The other thing is you have the other water loss, and salt helps you retain that. But for normal exercise, unless you're going more than 3 hours of strenuous exercise a day, what they found is the sport drinks really don't do anything. Well, I guess they cost you money. As I said that, I actually want to say that I am celebrating something, and I hope you guys will like this too. I recently reached 200 subscribers. And for me, it's the whole idea of round numbers. 200 is a big number for me. And so thank you for subscribing. And if you watch and haven't subscribed, please subscribe. And if you have any questions and you tell me, please mention me and my dojo or my school is this, I will put it down and I'll mention it. I hope this is helpful for you and hope to make more of these in the coming weeks. Thank you and goodbye.